So, guys, we are going to be working here on Newton's second law practice problems, and these are test type problems. So they're a little bit involved. They're going to ask about, it's going to be partially basing your understanding off of Newton's first law, all right, free body diagrams. It's also going to be, all right, test your understanding whether or not something is balanced or unbalanced. If something is balanced, what does that exactly mean? To know how to find the weight of an object, to know how to find the normal force of an object if it's on a horizontal surface. And then using, all right, the information given, draw a complete free body diagram, and then from there, use that to solve for either an acceleration or, if you're given acceleration, or coefficient of friction, solve for friction, solve for net force, potentially even solve for coefficient of friction. So we are going to start this. There may be one thing that you'd like to add. One thing that I would say would be potentially solid to add would be, all right, we have our F net is mass times acceleration. All right, you should know that mass is in kilograms. Our acceleration is in meters per second squared. Net force, or all forces, are in newtons. Friction force is in newtons. Normal force is in newtons. Coefficient of friction, no unit. That little dude there has got no unit. And then do we remember what the equation is for mass and weight? Okay, so Fg is your weight. Force of gravity acting on an object is an object's mass times gravity. We're going to use G is equal to 10 meters per second squared. So if I were to throw this into a triangle, guys, this piece down here, a little star next to it, this needs to be like, you don't even have to think about it. All right, you should just automatically, all right, realize, okay, if I'm given mass, I need weight, because that's going to help you go from, all right, and solve most of these type of problems. All right, so our weight on top, Fg, mass down here on the bottom, and if G is 10, then we can just, instead of writing G here, we can just write 10. So if I asked you guys, hey, I have a mass of, 50 kilograms, and I want Fg, if I cover up Fg, mass times 10, 50 times 10, 500 newtons. If I said I have a weight of 300 newtons, all right, if I have a weight of 300 newtons and I want mass, 300 divided by 10 will give me what the mass is. Why is that important? Well, because mass is going to be needed to help answer if you're solving for acceleration. You need mass, you'll need net force. Why is mass important in here? Because on a horizontal surface, Fg is equal to the normal force. And Fg is down here. So if I'm given mass, I do mass times gravity. That's going to tell me what Fg is, which I'll need to draw in downward. Horizontal surface, that means it's going to equal the normal force. That's going to be helpful, all right, because you'll need that in our friction force when we're solving for said piece of information. All right, so let's go through this now. All right, this dude is roughly a 6. All right, so this guy's here is a 13-point problem. I'll highlight everything that is worth a point at the end. So make sure you are doing it as required here. All right, I'm given a mass pulled across a horizontal surface. That horizontal surface, all right, being pulled across. So is it moving up or down? If the horizontal surface is not changing or causing this thing to move up or down, that means the normal force and gravitational force are equal. And what else? It says it has a coefficient of kinetic friction of this. So that little piece right there, that's this mu thing. All right, it's like almost if you did like a lowercase j, but without the period, and then basically attach like a u to it. That's this little fella down here. Okay, that's the Greek symbol mu. That is your symbol for coefficient of friction. All right, they want to know what the force of friction is exerted on the surface exerted by the surface on the block. Okay, well, pretty much, guys, I'm going to say, in all of these things, you have mass, find weight. So my first thing that I would want to do is I'm going to find Fg, mass times gravity. Okay, my equation down here at the bottom, Fg, mass times gravity. If I do mass times 10, I get Fg. So I'm going to do, mass was 12.5 kilograms, and gravity is 10. Guys, it's kind of hard to be writing this down if we're on our phones. Just put them away. Thank you. This is going to equal 125 newtons. So my next thing I would do is I'm going to draw that beast in. What direction does Fg always go, guys? Down. Good. So we're going to draw a little down arrow. Label that Fg, and I'm going to say that that is equal to 125 newtons. That'll be my step 2 and my second point. Am I on a horizontal surface? So that means, all right, that Fg is equal to Fn when I'm on a horizontal surface. So guess what I get to draw right now? Yep, Fn, and it would also be equal to 125 newtons. No math is needed for that, just your understanding. All right, I'm going to put 2 little equal lines through here. So I know my top and bottom are balanced. Okay, so I got 3 points out of my total 13. What else can I do? They ask, what is the force of friction exerted by the surface on the block? So can I calculate friction, guys? It'll be my next question. Can I calculate friction? Well, looking at this right there, do I have everything that I need? Do I have the normal force? Oh, yes. And do I have the coefficient? I do. So I can solve for FF. So that would be my next thing that I'm going to do. Friction force is equal to mu times normal force. Okay, mu was this number here, this 0.55. Times, what is Fn? 125. Yep, it's going to be the same as your F sub g. Okay, this comes out to be 68.75 newtons. All right. Now, if it's not given, it should be given, which I will make sure it is on your test. All right, this thing is, let's say, being pulled across a horizontal surface to the right. But for the most part, guys, all of our applied forces are going to be to the right, and friction force will be to the left. So can I draw in friction force? Yes. So I'm going to draw friction force to the left. All right, so FF is equal to 68.75 newtons. That would be my step 5. Now, I can't really do anything else right here in part A. Not just yet. But the part B says if the block is pulled by a 17 Newton force, remember, all right, a push or a pull, that is an applied force. So we're going to say that's going to the opposite direction. We're going to make this a little bit smaller. And F applied is 17. So that would be your step 6 to draw that in. So you need to make sure that you have all the forces labeled on your free body diagram. Labels and givens. All right, label givens and unknown. Show the equation. Use to solve for the unknown substitute values. Get the answer with the correct units for full credit. So right now we have 6 of our, all right, well, 6 steps, but I'll highlight everything that is going to be worth all of our points. They now ask, what is the net force on the block? So, guys, if you have 2 forces in the same direction, what do you do with them? Add them. And if you have two forces that are in opposite directions, what do you do? Subtract. So, normal force and gravitational force are opposite, but they're equal, so they basically balance each other out. So we don't have to worry about it. Are these two balanced, this left and right? No. So the net force will be equal to that 68.75 minus 17. This comes out to be 51.75 newtons. And what direction? Left. Okay, excellent. So we've got that down. Now they want to know what the acceleration is. Looking at this equation here, if I covered up A, what does A equal? F net divided by M. So A is equal to F net divided by M. And, okay, what the hell is my net force? Good, we just solved for that. And what was the mass? Very good, 12.5. And when we calculate this out, we're going to get somewhere around 4.14 meters per second squared. And what direction would the acceleration be? It's going to be to the left because that's the overall direction of my net force. So in this, all right, you get a point for showing the equation and the work here. So that's 1 point. 2 points for obviously getting that right number. 3 points for drawing that in. 4 points for drawing in the vector and labeling it. So we have 1, 2, 3, 4. Then we have normal force and the coefficient. So using this equation and showing work, this will be 0.5. This will be 0.6. 0.7, drawing and labeling that in. Doing this right here, literally just drawing that in. All right, so we have 1, 2, 3, 4, 5, 6, 7. This will be 0.8. All right, 0.9, you're going to get the subtraction here and your answer. And then this guy writing the equation, showing the work. 10, getting the right number. 11, getting the right unit. 12, and the correct final direction of the acceleration, 13. So each separate highlighted piece will be roughly your 13 points. So I want you to try number 2 right now. I want you guys to try number 2 right now. It is the exact same format as the first problem. So I want you guys to try that one right now. Again, guys, we should all be working right now on number 2. This is pretty much a test question that you're going to have on Friday. So definitely want to make sure we know how to do that. You got to make sure we're practicing that right this second. All right, so now that we've had some time to work on this, let's now roll through it. All right, so how we want to go about it is you have mass, you have coefficient of friction. Horizontal surface means that Fg is going to be equal to Fn. Okay, so first thing, if I'm given mass, I want to find my weight. Fg, mass times gravity. So I'm taking 37 times 10 because we're using 10 for G. This should have given us 370 newtons. So I'm going to draw that down. And because horizontal surface, Fg, and its opposing force, the normal force, is going to be the same going up. So Fg, 370 newtons. No math is needed for this one. Just my understanding that those two are the equal. 370 newtons. And I'm going to just put a little equal sign because they're not going to be involved in finding my net force. The next thing, I can find that my friction force. All right, why can I find friction force? Because friction force is the coefficient, which we already have, and the normal force, which we already have. So coefficient times normal force, you're going to use 0.65 times 370. Make sure you're using. All right, that was one of the only mistakes I saw as I went around. I think there's like 2 people that accidentally used the 37 instead of what you have to actually use as the normal force. The normal force, right? The unit for that has got to be newtons. So that's why it's the 370, not the kg. So we multiply this out, and you're going to get an answer of 240.5 newtons. Friction force, I said we were going to draw to the left. So FF, 240.5 newtons. Okay, we've done everything we can do because we've solved for that part of A. It says in part B, all right, if a block is pulled by a 48 Newton force, all right, being pulled, that's an applied force. They want to know what the net force is. I'm going to draw in my applied force. So the applied force is going to equal 48 newtons. Now, if my top and bottom balance, my left and right, they're opposite directions. They're not the same, so we got to subtract them. You're always going to take the higher magnitude, which is the 240.5, minus the lower magnitude, which is the 48. So 240.5 minus my 48. This is going to give us 192.5 newtons. And in what direction? Left, good, because the friction force was larger here. And then to find the acceleration, using this equation up here in this triangle, covering up A, F net divided by M. So we're going to write that equation in. And you're going to use this 192.5 over, what was my M again? 37. And we all should have come out with 5.20 meters per second squared left. And again, the points on this, writing the equation and work, 1 point. Getting that answer, 2 points. Drawing it in, 3 points. Knowing that normal force and weight are the same, drawing that in, 4 points. Knowing that we have normal force and coefficient, all right, write the equation and do that work, 5 points. Getting the right answer, 6. Drawing it in, 7. Okay, giving an applied force here, 48, and drawing that in, 8 points. Okay, getting our correct work here done for net force and getting our answer, 9 points. Writing the right equation, 10, and showing the work. So 10, getting the right number, 11, getting the right unit, 12, and direction, 13. All right. Very happy with what we saw there. Now the next one. We have a 5 kilogram block pulled horizontally across the surface by a 25 Newton force at constant velocity. So this tests our knowledge back for Newton's first law. All right, if there are balanced forces on there, on an object, is there going to be any change in the object's motion? No, it has to be an unbalanced force, all right, to cause a change in motion to an object's inertia. So I'm just going to add this little piece here, constant velocity means the F net is equal to 0. That will be importante. All right, they give me mass, and they give me a pull force or applied force of 25. So I can already draw that in because that's the beautiful and given. So that would be F applied 25 newtons. Okay, guys, when you see something is constant velocity, that means the net force is equal to 0. So let me ask you guys right now, if I have a force going to the right at 25 and the net force needs to be 0, does there need to be a force going to the left?
Yes.
Okay. And what size would that force need to be? Equal to this. So it would be 25 going to the left. And that would be our friction force. I'm going to put a little equal sign there. Bing bong. The fact that we have a horizontal surface means that our weight will be equal to normal force, just like in the first two problems. So, all right, bet. Let's go about solving for. Let's go about solving for weight. Fg is m times g. Mass is 5. G is 10. 5 times 10, 55, right? I sorry. Yes. No, I wasn't. That's not what I was trying to do. That's not what I was trying to do. Oh, I'm sorry. I didn't mean that. I didn't mean that. So I thought it was like a layup. All right, my bad. My bad. Next, what should I do if I have this? Good, draw it in. $50 newtons, very good. And draw in my normal force, which is also 50 newtons. Again, that one needed no math. So if I do this, guys, guess what? All my forces are balanced, and my net force is 0. This is excellent. All right. What is the force of friction acting on the block? Well, it had to be 25. All right, because if the F net is 0, everything must be balanced. Because everything must be balanced. Okay. And the last thing, it says find the coefficient of friction. All right. What is that, guys? What symbol is that? This guy right here. All right, so I need to find this dude. This is my coefficient of friction. So what is that? I would have to do what by what? Friction force divided by normal force. And it would be 25 over 50, and I would get a coefficient of 0.5. Now this thing does not get a unit. Okay, so we drew in the applied force. 1. All right, figuring out our friction force of 25. It's the same thing because we had to draw that in. Then we figured out the mass, or we figured out the weight based off of our mass. So we did this, got our number, drew that in, drew that in. So right now we're looking at 1, 2, 3, 4, 5, 6. Writing the equation and showing the work. 7, 8. So 1, 2, 3, 4, 5, 6. Yep. Actually, I guess technically 9. So that would be 7. This would be 8. This would be 9. Okay, the last problem I want you to do for this, we're going to add this in. Going to add this in. Sec. A mass of 400 kilograms is pushed to the right, the coefficient of friction mu is going to equal 0.70. And the mass accelerates at 0.55 meters per second squared to the right. A. All right, add your drawing. And we want to say, what is the friction force? Damn it, I need to draw this down a little bit more. B what is the F net? And C, what is the applied force? All right. So guys, am I given mass? If you're given mass, what should you do? Find very good, excellent. Find FG, 100%. That should be my first step. FG, mass times gravity. (400 times 10). And that's going to give me a weight here of 4,000 newtons. And then I'm going to draw that guy in. Okay, if it doesn't tell us, all right, we are already to assume that it is on a horizontal surface. So we have FG is 4,000. What would Fn need to be? 4,000. Guys, if you can do that for every problem, you can start to then chip away at everything else. They ask, what is the friction force? Do we know what the equation for friction is? Friction force is equal to coefficient times normal force. So that would be what I would do next. The coefficient is 0.70. And my normal force is 4,000. And this should come out to be 2,800 newtons. Okay. If this thing is being pushed to the right and moving to the right, what direction should I draw in my F net? Or I'm sorry, my FF? if this thing is being pushed to the right, what direction should friction go? Opposite to the motion. So we would draw it to the left. $2,800 newtons. Those two are equal. Let me ask this now. Is my applied force going to be 2,800? Is this push force that I'm using, is it going to be 2,800? No. Why? Because it doesn't tell us that this is moving at a constant velocity. In fact, it tells us that it is accelerating to the right, which means we need to be making sure that we have a rightward force that is larger than our F. Okay, well, dang, how do I do that? Well, they asked us, what is net force? Now, before in some of these drawings, once we had enough information to draw in all of our vectors and then just subtract. But right now, we don't, because we don't know what this applied force is. We have to figure that out. So in that case, we need to use this triangle. F net is mass times acceleration. Do we have the mass? Yes. Do we have the acceleration? Yes. So we will have the mass of 400, an acceleration of 0.55, and this will give us a value of 220 newtons. It's got to be to the right, the net force. And why or how do I know that? Because the acceleration is to the right. Net force and acceleration have to be in the same direction. So this last one is, again, just your understanding of Newton's first law. All right, balanced and unbalanced forces, and when we did a little bit of the mechanical equilibrium. If the net force needs to be 220 newtons to the right, very, very good. That means that this, all right, our applied force vector, it needs to be 220 newtons bigger than our leftward force. So I would have just did, okay, well, 28 plus 220, all right, like Nat said, comes out to be 3,020 newtons to the right, but we don't have to necessarily draw that. We do have to draw it in, though. Okay, so what we do, we went and we found weight, 1 point, 2 points. Draw that in, 3 points. Draw this in, 4 points, because there's no math needed for that. Now that we have normal force and coefficient, you can find friction force. So this would be my 5th point, 6th point. Draw it in, 7th point. You have enough information to find this. 8th point, 9th point. And then pretty much figure it out. 10th point, 11th point. Yeah. All right, so guys, this is going to be, this right here is going to be your homework. that we'll have time right now in class to start. It's using the worksheet that we had just finished, as examples. This should be very, very helpful, and pretty much guys you. So I would say definitely try and get through as many of these as you can right now. Don't just shut it down, so we actually don't have to worry about homework. That way, also, if you get stuck on something, you can let me know. Okay.
Hand them out individually or just